to the next module of graphical MCQs. Students, these kind of MCQs are the ones which needs the most attention since the graph says too many things from its x-axis and the y-axis. The very first question that you have is given as follows. From the graph, you can see the graph is about stopping potential being against frequency for two metals, that is sodium and aluminium. You can see the stopping potential being on the y-axis and frequency being on the x-axis. Since frequency is independent and stopping potential is dependent on frequency, we infer that means what can we conclude from the graph? The options are aluminium is a better photosensitive material than sodium. Option B is that the stopping potentials are different for Na and Al for the same change in frequency. It also says that the maximum kinetic energy for both the metals varies linearly with the frequency. And option D, it says that sodium and aluminium both have same threshold frequency. Now you can see that they both are starting at different points. That means they do not have same threshold frequency. And hence, can I say that sodium is a better photosensitive material? That is why option D and option A is not correct. So how do we go ahead about the solution of this problem? We know that in photoelectric effect, half mv square, that is the kinetic energy, is equal to E into Vs. So can I say the relation between kinetic energy and the stopping potential is direct relation? So can I say on the basis of that the stopping potential will vary linearly with the frequency? So can I say stopping potential varies linearly with the frequency means the relation is direct. Hence the maximum kinetic energy will also vary linearly with the frequency. And such an option which says that the maximum kinetic energy for both the metals varies linearly with the frequency will be the correct option, and that option is option C. Moving ahead to the next problem. In the next problem, it is given that for a photosensitive metal surface, the graph of stopping potential, that is V0, is plotted against the frequency, that is nu, of the incident radiation as shown in the figure. What is the work function of the metal? And the options given are 15.5 electron volt, 17.8, 20.6 or 24.5 electron volt. Now you can see in the graph, the frequency is there on the x-axis and stopping potential on the y-axis. Frequency being the independent term, hence it is on x-axis, and stopping potential being the dependent term, it is on the y-axis. Can I say, for a less frequency, there will be no photoelectric current and hence no stopping potential. That means, can I say, in the less frequency region, you can see there is no stopping potential. Stopping potential only starts after one particular frequency is overcome, and that frequency will be called as the threshold frequency. So can I say, from this case, I know that if I need to find out work function will be h into nu naught. And nu naught, that is the frequency in this case, is given as 6.6 into 10 to the power minus 34, that is the value of h. And nu naught, that is the frequency, is given in the terms of 10 raised to 15 hertz. So that is phi. Since it cuts on the phi point, it is phi into 10 raised to 15 hertz. So after substituting this value, I get the final answer of work function as 33 into 10 raised to minus 19 joules. Now remember students, the answer is in joules, but joules is not the correct option. We have options in electron volts, so we need to divide it by 1.6 into 10 to the power minus 19. That is why we divide it and we get the answer of work function as 20.6 electron volt, that is option C. We move ahead to the next graphical question. In this question, you can see in an experiment of photoelectric effect, the frequency nu of the incident light is plotted against the stopping potential. So you can see the stopping potential is there on the y-axis and frequency on the x-axis. The question is given as the work function of the photoelectric surface will be given by. So what is work function given by? Option A is OB into E in electron volt. Option B is OB into electron volt. But can I say OB is the potential only? so that won't make sense. OA in electron volt, again OA will be the frequency in electron volt, so that also does not make sense. The next option is the slope of line AB. Now that part also you need to check. So in short, can I say that all these parameters you need to check? So to solve the problem, I can write the Einstein's photoelectric equation, which says that the kinetic energy maximum will be h nu minus h nu naught. So can I say EV naught, that is kinetic energy maximum, which is equal to h nu minus h nu naught? In that case, I can write this as h nu minus w naught. So to move ahead and to understand and to take E on one side, I'll get V naught as h upon E multiplied by nu minus W naught upon E. Students, how did I get this? I get this by taking E on the other side. So by taking it on the other side, it comes in the form of division. Now since V naught is on the y-axis, I can equate this equation with y is equal to mx plus c. And on equating, we find that the slope is given by h by E and the y-intercept is given by W naught upon E. Now this y-intercept, that is OB, which is equal to W naught upon E. So can I say W naught will be OB into E in electron volt, which is your option A. So hence students, with the help of this concept or this problem, we studied the problems which are related to the concept of graphs. We will be studying more problems on the same in the next coming module. Till then, thank you.